Okay. Bismillah ar-Rahim. We'll continue. Now we did these problems. Now we'll continue to the next one. Solve the initial value problem. Now it's just 2 by 2 matrix, but the addition is that we have initial conditions. So I need to find the C1 and C2 after I finish. Okay. Now we'll start to find the lambdas. A minus lambda I. That give me what? 3 minus lambda. That give me 3 minus lambda. Minus 1, 5, minus 3 minus lambda. That will be lambda square. 3 lambda minus 3 lambda gun. Huh? 3 lambda minus 3 lambda gun. Nothing is there. Minus 9. Okay. Plus 5. That give me lambda square minus 4 equal to 0. So lambda equal plus or minus 2. Oh, okay. Now we'll work out lambda equal minus 2. Call it lambda 1. Okay. So I have here lambda 1 minus 2, lambda 2, call it 2. Usually I like to start with the negative one, with the smallest one. Okay. Lambda 1 equal minus 2. So I let V1, K1, K2, and solve this. A plus 2I, V1, which is 3 minus minus 2, that will be 5 minus 1, 5, minus 3, plus 2, minus 1. Yeah, very clear. Equals 0, 0. So I have K2 equal 5 K1. Correct? Yeah. 5 K1 minus K2 equals 0. So K2 equal 5 K1. So let K1 equal 1. K2 will be 5. So V1 will be 1, 5. And X1 will be 1, 5 E minus 2T. Easy one. Now for lambda 2 equal 2. I let V2, K1, K2, and solve this system. A minus 2I, V2, which is equal to what? 3 minus 2, that is minus 1, minus 1. I have 5, minus 3. Sorry, 3 minus 2 is 1, huh? Not minus 1, 1. This is 5 minus 3. Minus 2, that is minus 5. Times K1, K2 equals 0, 0. Very clear, I have K1 equal K2. So if I let K2 equal 1, I let K1 equal 1. So V2 is 1, 1, and X2 is 1, 1, A, 2T. Okay. Now, well, what I will have, my general solution, X will be C1, X1 plus C2, X2. And that is equal to what? C1, 1, 5, A minus 2T plus C2, 1, 1, E2T. Now I need the condition to find C1 and C2. What I have the condition? I have X at 0 equal 2 and 10. And that at 0, I have what? C1, huh? E to the power 0 is 1, so I have C times 1 plus C2. In the second row, I have what? 5C1 plus C2. So I have this system. I have C1 plus C2 equal to, and 5C1 plus C2 equals to 10. I subtract these two equations. I have minus 4C1 equal to what? Minus 4C1, 2 minus 10, that is minus 8. So C1 equal 2, plug it here. So C2 equals 0. So it will be my solution. C1 is 2, C2 is 0. So I have 2, 10, E minus 2t, or can rewrite it, which is this one. Great. Now let me do another problem. Yeah, the same idea. But now what will happen? Yeah. You know what? Let me do this one, then I'll do the next one, because this one I need the, yeah, this one will be solved using the nonreal roots. Then I will do the next one where I need to find where I need to solve it. Okay, so do a minus lambda I to find the eigenvalues. I have 2 minus lambda 1 minus 1 2 minus lambda. I have 2 minus lambda squared plus 1 equals 0. In other words, I have lambda square. Yeah, let me do it. Well, I can make it to the other side, it'll be okay. But let me, lambda square minus 2 lambda minus 4 lambda plus 4 plus 1, which is lambda square minus 4 lambda plus 5 equals 0. Cannot factor it. I can find lambda. Lambda will be what? 4 plus or minus square root b square 16 minus 4 AC over 2. 16 minus 20 is minus 4, so that will be 4 plus or minus 2i over 2, which is 2 plus or minus I. Okay, so lambda 1 is 2 plus I, lambda 2 is 2 minus I. Okay, now I'll work out lambda 1, 2 plus I. Yeah, usually I work the one with the plus. I need to find, I let V1, K1, K2, and solve this system. Yeah, let me leave it minus lambda 1 I V1. And that will be what? 2 minus 2 minus I, that will be minus I. 1 minus 1. 2 minus 2 minus I, that will be minus I. Yeah? 2 minus 2 minus, that will be minus I times K1, K2. That should equal 0, 0. So what I have, minus I K1 plus K2 equals 0. And minus K1 minus I K2 equal 0. These two equations should be the same. Notice I multiply the second one by I. I'm getting minus I. Minus I times I is plus 1, which is correct. So I have K2 is equal to I K1. K2 is equal to I K1. So now let K1 equal 1. I get K2 equal I. So my V1 will be 1I. This I will split it into two parts. 1, 0 plus I 0, 1. We call this B1. We call this B2. Yeah, just to remind you, I will use this formula now, where B1 is the real part of the eigenvector and B2 is the imaginary part. So these will be my solutions. Yeah, I left this one, then we'll go back to it. So the real part 1, 0, this is I 0, 1. So my solution, first solution is what? Let me take the formula B1 cosine beta t plus minus B2. Let me write the formula B1 cosine beta t minus B2 sine beta t e to the power alpha t. Yeah, by the way, when I have this, don't forget my lambda should be alpha plus beta t plus I beta, I mean. So my alpha is 2 and my beta is 1. Okay, when I plug it here. So this one, x1 will be what? b1, 1, 0. Cosine, what is beta? Beta is 1, خلاص. Minus b2, 0, 1. Sine beta, sine t, e to t. And this is what? This will be cosine t, huh? That will be cosine t minus sine t, e to the power 2t. That will be x1. x2. Okay, just to remind you about the formula. What is x2? b2. I change, interchange b2, b1 with b2, and I change the sign. And exactly it will be this. So it will be b2 instead of b1. I'm doing it in detail. Cosine beta t. This will be plus b1 sine beta t e alpha t. Yeah. That will be what? I will put b2 here now. What is b2? 0, 1 cosine t plus b1, which is 1, 0 sine t e to t. And that give me what? Sine t, huh? And the other one cosine t e to t. Okay, so what is my general solution? X would be C1 X1 plus C2 X2. And that is C1 cosine t minus sine t e to t plus C2 sine t cosine t e to t. Yeah, which is the same. Yeah, and this one just multiply by minus 1. Huh? And then meaning the first one. Cosine t minus sine t. This is just minus sine multiplied by. So this is correct. That is my solution. Now let me go back to this one where I have initial condition. And instead, now after I finish the calculation, I need to do initial condition. Okay. Now, let me do it again. So I have a minus lambda I. Let me do it quickly. 2 minus lambda minus 1, 5, 4 minus lambda. That give me lambda square. Minus 4 lambda minus 2 lambda. This is minus 6 lambda plus 8 plus 5. That will be plus 13 equals 0. So it will be lambda 6 plus or minus square root b squared 36 minus 4 times 13 over 2. That will be 6. 36 minus 52 minus 16. That will be 6 plus or minus 4i over 2. That will be 3 plus or minus 2i. So lambda 1 will take the positive. So I have alpha equal 3 and beta equal 2. Okay. So let v1, k1, k2, and solve this. A minus lambda 1i, b1, which is what? 2 minus 3 minus 2i, that will be minus 1 minus 2i, and minus 1, 5. 4 minus 3, that will be 1 minus 2i, times k1, k2 equals 0, 0. So we have these two equations, minus 1 minus 2i k1 minus k2 equals 0, and 5 k1 plus 1 minus 2i k2 is equal to 0. Yeah, these two should be the same. Believe me, they are the same. Yeah. Multiply by, let me say by what? They are the same. Look, if you multiply by by y minus 2i, or 1, I need the minus sign, by minus 1 plus 2i. What you will get? Yeah, so I need the minus sign, because I need the minus sign. That will give me what? 1 minus 4i squared, which is 5, which is this one. So it's correct. So there are only one equation. Yeah. So I can get easily that K2 is, take it the other side, minus 1 minus 2i K1. So if I let K1 equal 1, K2 is minus 1 minus 2i. So my V1 will be what? 1 minus 1 minus 2i, which is 1 minus 1 plus 0 minus 2i. So this is my B1 and this is my B2. Yes. Okay. Now I'll find the solution. X1, let me write it quickly. B1, write the formula. B1 cosine beta t, minus B2 sine beta t, A alpha t. That is what? What is B1? B1 is 1 minus 1 cosine 2t. Beta is what? 2 and alpha is 3. Okay. Minus B1 0 minus 2 sine 2t all times e to the power 3t, which is, I can write it, cosine 2t minus cosine 2t plus 2 sine 2t times e 3t. Okay. Yeah. Now let me do x2. And now that apply the condition. Okay. Yeah, let me do it quickly. That will be B2 now instead of B1. So it will be 0 minus 2 cosine beta t, but beta is 2. No worries. Plus B1, which is 1 minus 1 sine 2t e 3t. In other words, it's what? It's sine 2t, and this one is minus 2 cosine 2t minus sine 2t e to the 3t. Yeah. What will be my general solution now? X will be C1, X1. Yeah, let me rewrite it. C2 times what? Sine 2t minus 2 cosine 2t minus sine 2t e to the power 3t. Now I need the condition to find C1 and C2. Okay, let me try to squeeze it here. X at 0 will be what? Cosine 0 is 1, that will be C1. Sine 0 is 0, gone. In the second row, minus 1. Sine 0 is 0. So it's minus C1 minus 2C2. And that is equal 1, 1. So C1 is equal to 1. And what I have? And minus 2 C2 is equal, take C1 to the other side, 1 plus, that's equal to 2. So C2 equal minus 1. Okay, so it will be my solution. Now C1 is 1 and C2 is minus 1. Okay, so that will be cosine 2t minus sine 2t. All times E3t. Okay. And in the denominator, I have what? Minus cosine 2t. Be careful here. I think I need more space. Plus 2 sine 2t. C2 is minus. I have plus 2 cosine 2t plus sine 2t. E to the power 3t. And that will be what this is, will not be affected. Minus sine 2t. This one will be minus cosine, that will be cosine 2t. 2 plus 1 plus 3 sine 2t e to the power 3t. Which is very clear. I have 1 plus 1 minus 1, correct? I have 1 cosine plus 3 sine, which is correct. So this is my answer. Okay, not difficult, but it's calculations. It needs calculations, you know. So we did now 2 problems. This is just you do just the calculation. You have the formula. You just apply the formula. Yeah, this one is a little bit complicated. Yeah. Let me see what will happen. First, I need to write it in the matrix form. X prime. Yeah, let my capital X, X1, X2, X3. Huh? So I have X prime equals what? 5, 5, 2. Okay. Minus 6, minus 6, minus 5. 6, 6, 5 times X. So I need to find the eigenvalues. A minus lambda I. Yeah, that will take some time. 5, 2, minus 6, minus 6, minus lambda, minus 5. I don't think so. I would see something like this in the exam because it's too much calculation. Yeah. I need to do the calculation. See what will happen. I'll do the expansion. You know what? Let me multiply. I can do this trick. Multiply the second row by 1 and add it to this third row. So at least I have more zeros. 1 times minus 6, that will be 0. Then I add this. That's nice. Becomes minus lambda. And this is also minus lambda. Yeah. Now we'll do the expansion with the... Yeah, let me do it with the third row. With the third row. So I have what? This is plus, minus, plus. This is negative, so I have lambda. Cancel the third row and the second column. Third row and second column, I have 5 minus lambda. 5 minus 6 minus 6 minus lambda. Minus lambda, plus, minus, plus, minus lambda. Cancel the third row. Third column. I have 5 minus lambda. What is this? No, wait a minute. This is not correct. I'm canceling here the first row, say third row, second column. So that will be 2 and minus 5. 2 and minus 5. Minus lambda. This one will be 5 minus lambda minus 6. Third row, third column. 5 minus 6 minus lambda. Yeah, let me do the calculation. I have lambda times what? This is what? 5 lambda minus 25. 5 times 5 is minus 25 plus 12. minus 25 plus 12, this is minus 13. Okay, minus lambda times what? I have here lambda square. Okay. 6 lambda minus 5 lambda, that will be plus lambda. Minus 30 plus 30, gone. خلاص. That is nice. So you can take lambda common factor. They have what? 5 lambda minus 13 minus lambda square minus lambda. So that will be lambda. Take a minus common factor. Let me at the same time take a minus common factor. I have lambda square, 5 minus lambda. This is 4 lambda with a minus sign, minus 4 lambda plus 13 equal to 0. So I have lambda equals 0. Nice. Or lambda 2, the solution of this, which is 4 plus or minus square root 16 minus 52 over 2, which is what? This is minus 36, so it will be 6i, that will be 2 plus or minus 3i. So my alpha is 2, and my beta is 3, which is correct. So now for lambda 1 equals 0. Yeah, what will happen? Let's solve the system. Yeah, I'm doing it quickly. K1, K2, K3. Let's solve the system. 5, 5, minus 0, which will not affect anything, will not make any effect. 6, 6, 5 times K1, K2, K3 equals 0, 0, 0. Yeah. Yeah, I'll try to do this. I think Gauss elimination will be better. We do Gauss elimination. Let me do a trick also, the Gauss elimination. Yeah, this is 5, 5, 2, minus 6, minus 6, minus 5. Multiply by 1 and add, that will be 0, 0, 0. Yeah. So that gives me 5k1 plus 5k2 plus 2k3 equals 0. Let me make it this 6k1 or make it minus. I think minus is better. Yeah, you have 3 equations, three unknowns. Try to manipulate it the way you like. Yeah, I notice you multiply here by 6, multiply here by 5. You get what? Yeah, this is I'm doing lambda 1 still, huh? You have 30k1 plus 30k2 plus 12k3 equals 0. And this is minus 30k1 minus 30k2 minus 25k3 equals 0. For sure, I'm getting k3 equals 0. Because this will be cancelled. You have something times k3 equals 0, so k3 equals 0. So that implies, and also I have what? If k3 equals 0, I have k1 equal minus k2. So I let k1 to be 1. I get k2 equal minus 1. The other way, I let k2 equal minus 1. I want to see the same answer. That implies k1 equal 1. So my b1 is 1 minus 1, 0. And by the way, x1 is the same as v1, since it's e to the power 0. Okay. Now we need to do, the next one. For lambda equal, this is a little bit complicated. Let me take it to the next page. So now for lambda 2, which is equal to what? Lambda 2 equal to what? 2 plus 3i. I take the positive one. Since the procedure, we need to apply the positive. Huh? Let v2, k1, k2, k3. So I have this system. 5 minus 2 minus 3i, that will be 3 minus 3i, 5, 2. Okay. Minus 6 minus 6, minus 6 minus 6, minus 6 minus 2, that will be minus 8, minus 3i. And the last one is what? Minus 5. And I have 6, 6, 5, 6, 6, 5 minus 2. That will be 3 minus 3i. I need to solve this system. Yeah, not an easy one. This is minus 5. Yeah, this is minus 5. How to solve this system? Complicated one. It is. Let me try to do Gauss elimination, see what will happen. At least I try to get rid of some numbers. Make zeros. So if we're doing this, multiply the first, not the first. Multiply the second row by 1 and add it to the last row. So this will be the same. Add 1, that will be 0. This is with 1. That will make it complicated. Yeah, it will be minus 2 minus 3i. And the last one, minus 2 minus 3i. 0. Nice. Correct? Yeah. Now if I divide by minus 2 or minus 2i, I'm getting what? 3 minus 3i, 5, 2, 0. Minus 6, minus 8, minus 3i, minus 5, 0, 0, 1, 1, 0. Nice. Okay. Now what shall I do? How to solve this? So from here, I'm getting that K2 equal minus K3. Is it? Get the answers. Be sure what I did is correct. Yes. Now I plug it into the first equation. So I'm getting now 2 equations. Plug it here, plug it here. I'm getting 2 equations. I'm getting 3 minus 3i times K1. Okay. I have, instead of K2, I'll write minus 5K3 plus 2 K2. Let me do it in a step, at least the first. This equation is 3 minus 3i K1. K2 is minus K3, so it's minus K3 plus 2K3. That will be minus 3K3 equals 0. The second one, let me do it right away. Yeah, no, I need to do it in steps. Minus 6K1 plus minus 8 minus 3i K2 minus 5K3 equals 0. So I have what? Minus 6K1. Now multiply by minus 8 minus 5, that will be 3. Minus 3i K3 equals 0. Okay. These two should be the same. Believe me, they should be the same. Okay. Now multiply the first one. Let me multiply the second one. This by minus 1 plus I. Yeah, so that will be 3 minus 3i. Now 3 minus 3i with minus 1 plus I. That give me what? Should give me minus 6. That will be minus 3. 3i plus 3i. That give me 6i. Minus 3i squared plus 3. Oh, there's something wrong. 3 minus 3i. K1. Minus 5 plus 2. That will be minus 3k3. Multiply this by minus 1 plus I. That give me 3 minus 3i. Now let's multiply this by minus 1 plus I. Give me what? Minus 3. 3i and 3i. No, there's something wrong. Yeah, let me double check. 5, 2 minus 6 minus s minus 3 minus 5, 6, 6, 3 minus 3i. Okay. What I did here, this is the system. I make it in this way. Be sure. Just I want to be sure about the calculation. It's a calculation matter. 5 minus 2, that will be 3 minus 3i. Okay. Minus 6 minus 8 minus 3i. And that's 1, 5. Okay. Now I multiply by 1 and add. That will be 0. Multiply by 1 and add. That will be minus 2 minus 3i. And that will be minus 2 minus 3i. Good. So I divide by minus 2 minus, that will be 1. Great. So this is correct. So I have K2 equal minus K3. Now let me write the equations. 3 minus 3i. This is 5, 2. I'm taking them correct. No minus sign, nothing. Yeah. Now plug K2 minus K3. I think there is a minus sign somewhere. That will be minus 5k3 plus 2k3. This is minus 3k3. Correct. Now the next one, minus 6k1 minus 8 minus 3ik2 minus 5k3. Is it? Yeah. So I have minus 6k1 plus. Now I plug instead of k2 minus k3. So I have plus 8 plus 3i. Sorry, this is plus 3i. Yeah. I think that will make it, yes. So I have 3i minus 3i gone, minus 3 minus 3. That will be minus 6. Correct. Now everything is correct. So it usually is good to check. So I have now K1. Right, K1 is what? These two equations are the same. Yeah. K1 will be careful with the minus sign. Minus, so I have everything is plus 3 over 6 plus 3 over 6i times K3. So I let K3 to be 2. K1 will be what? Will be 2. Yeah, 2 will make it. Yeah, it will be 1 plus I. So my V2 will be what? Yeah, is it correct? K3 equal 2. So I have 2 times 3, 6. Yeah, it will be 1 plus I. So my V2 K is 1 plus I. K2, what is K2? I defined K2. Yeah, K2 will be minus K3, which is minus 2. And this is 2, which I can write it 1 minus 2, 2, plus 1, 0, 0, I. So this is my B1, and this is my B2. Yeah, a little bit complicated, but I think we'll get it at the end. So I have X2. Since I have X1 with the lambda equals 0, I have X2 with this lambda. It will be B2, B1, B1 cosine beta. Beta is what? Where is beta? Beta is 2. Beta is 3, I mean. Beta 3t minus 100 sine 3t e to the power 2t, which is what? Cosine 3t minus sine 3t and minus 2 cosine 3t. This is 0 and 2 cosine 3t times e to the power 2t. Okay. And x3 will be what? Just reverse them. 0, 0 cosine 3t plus 1 minus 2 to sine 3t e 2t. That is what? Cosine 3t plus sine 3t. Yeah. And minus 2 sine 3t and 2 sine 3t. Yeah, e to the power 2t. What will be my general solution? C1 x1 plus C2 x2 plus C3 x3. Let me double check. Yeah, this is correct. This one is cosine minus sine, minus 2 minus 2. Perfect. This is also correct. The last one, cosine side sine minus 2. Where is it? No. Yeah. Cosine side sine minus 2 and 2. Perfect. Yeah. We can write it this way or we can write it this way. So my calculation is correct. That's a little bit, lengthy one. I don't think you will see it in an exam because it is too much calculation. Yeah. Usually we'll see something like this, 2 by 2 with initial conditions, sometimes with no initial condition. But this is, since doing it one time, just for the information. The complication is how to solve this system of equations. Yeah, just you need to see some tricks to do that. The rest are just 2 by 2. So let me try to finish this so that the remaining will be all the exams and suggested problem on the book exercises. Yeah, I have a minus lambda I. This for the complex, very clear, with the answers. 6 minus lambda minus 1, 5, 4 minus lambda. That give me what? Lambda square minus 4 minus 6 minus 10 lambda. Yeah. 24 plus 5 plus 29 equals 0. So lambda will be what? 10 plus or minus square root 100 minus 4 times 29 over 2. That will be 10 plus or minus. 4 times 29 is what? 4 times 30 is 120 minus 4. This is 116. That will be square root of minus 16 over 2, which is 4. So it will be 5 plus or minus 2i. So alpha equal 5 and beta equal 2. This is what I need. Now, for lambda 1, which is 5, I'll take the positive value always. I let V1, K1, K2. So I get what? 6 minus 5, that will be 1 minus 2i minus 1, 5. 4 minus 5, that will be minus 1 minus 2i times K1, K2 equals 0, 0. So I have these two equations. Usually I check into these two equations are the same as a checkpoint for me. Yeah. So I need to multiply this is with 1 plus 2i. So 1 plus 2i times 1 minus 2i, that will be 1 plus 4, which is 5. So it's correct. So I have K2 is 1 minus 2i K1. I let K1 equal 1. I get K2 is 1 minus 2i. So I have my V2, my V1 is what? 1 minus 2i, which I can explicit 1, 1, 0 minus 2i. So this is my B1 and this is my B2. Okay, my first solution, B1. Yeah, let me do it quickly. 1, 1 cosine 2t Yeah, I think this should be 1, not 5. Was it 6 minus 5, 1 minus 2i, 4 minus 5, minus 1 minus 2i. So these two equations are the same. Yeah. Yeah, it depends. let me just check what I did is correct. K2 will be 1 minus 2i K1. Yeah. So if K1 equal 1, K2 will be 1 minus 2i. If I choose the other case, the other way. Yeah, I think I'm doing right. Okay. This is cosine. What is alpha? What is beta? Where is it? Beta is 2, cosine 2t minus b2, which is 0 minus 2 sine 2t times e to the power 2t, e to the power 5t. My x2 will be what? Reverse them. 0 minus 2. Yeah, I think he's using a different way. Cosine 2t. But at the end they are the same. Plus 1, 5 cosine sine 2t. Or not 1, 5. What was 1, 1? Yeah, this is my b1 cosine minus b2. This is b2 1, 1 sine 2t e5t. My general solution x will be c1 x1 plus c2 x2, which is correct. Yeah, don't be bothered. He has a different way. I think he was using this equation. So that make it a little bit complicated. No, not that complicated. If you look at this, you have what? Just to be sure that what we did is correct. 5k1. 5k1 is what? Is 1 plus 2i k2. So k1 is 1 plus 2i over 5k2. So he let k2 to be 5. So it will be k1 is 1 plus 2i. So he has 1, 5, 2, 0. So this is B1 and this is B2, which is the same. Okay. Now let me do this one, then I will stop because the remaining are all the exams. And we'll show you also all the exams. It will not be that complicated. Yeah, will not take that long time to do. So I have A minus lambda I. Let me try to do it quickly. 4 minus 2, 3, 3, 4 minus lambda. That will be lambda square minus 8 lambda plus 16 plus 9 plus 25 equals 0. So lambda will be what? 8 plus my square root 64 minus 4 times 200 over 2. This is 36. So it will be 6. So it will be 4 plus or minus 3i. Yeah. So alpha equal 4 and beta equal 3. So now for this eigenvalue, the positive one, I have what? Minus 3i minus 3, k1, k2. Huh? This is 3 minus 3i. This is 0, 0. So I'm having what? Minus 3i, k1 minus 3, k2 equals 0. As I said, usually I try to use this as my checkpoint that what I did is correct. So multiply by I, the first one, you get 3, which is correct. So I have what? Yeah, I can say k2 equal what? Take it 3. No, I don't want to divide by I. So I have k1 equal what? 3. Yeah, k2 is okay. K2 will be equal. Take it to the other side and divide by 3. So I have minus I k1. So I let k1 equal 1. K2 will be minus I. So my V1 will be 1 and minus I. That is 1, 0 plus 0 minus 1 I. Maybe they have a different answer, but it's okay. I think they are the same. He's doing it the other way. He's using the second equation, this one. Yeah, I think he's using this equation. But it's okay. Where he has K1 equal IK2. So if K2 equal 1, K1 will be I. So you have I and 1, which is what? 0, 1. No. Yeah, it will be 0, 1. This is my no. This is have 0 minus 1. This is my B1. Yeah, there is a minus sign. Yeah, he's using the same one, but with the minus sign. This is B2. So my solution, yeah, I'll show you, it's only a minus sign problem. B1, huh? The formula. Yeah. B1 cosine beta, huh? So I have B1, which is 1, 0 cosine beta. What is beta? 3t minus the other one, 0 minus 1 sine 3t e to the power 40 and x2 the other way, 0 minus 1 cosine 3t plus 1, 0 sine 3t e to the power 40. If you look at this solution, it's the same as this one, with the minus sign, multiply by minus sign. Since you have a constant, that will not make a difference. Multiply everything by minus 1, you will get this one. And the second one, yes, the same thing. Multiply by minus 1, you will get the second one. So my general solution, x will be C1, x1 plus C2, x2. Yeah. The remaining is just, I'll do examples from, all the exams questions, which you don't need to do all of these things. Yeah, sometimes he will give you some calculation things so that to make it easier. Yeah, I'll do it later, inshallah, the next video. So I think now things are clear. Just we need to do examples. Let me stop the recording. Thank you.